Greetings, friend. I will show you how Simon Anthony solved this classic Sudoku by Shye called Smile, and I'll explain all of his Sudoku tips, tricks, and strategies that he does. I will also give you some positive video and what-if moments to help you analyze some alternate solve paths. You're going to want to watch this whole video because there's some great techniques and strategies learned all the way to the end. Click below if you want to give it a go or see the original video, and with that, it's solving time. So real excited about this because Simon hasn't done class Sudokus in a few months. This one just came out in October, and he starts off by looking for the fives and says, hey, I can actually solve a five. There's a 5 and a 5, and these two fives come down, so he solves this for a 5. Then he goes into some cross-hatching. Says, okay, with the ones, I got 2 1s down there. I'll make that mark. I got 2 3s here in block 5 because of the 3 here and here and coming up 5. Then he looks and says, wait a minute, can I actually solve another 5? And he sure can. And so this leads to some more solving here. So you got a 5 here and a 5 here, and he notices these 2 5s. So he's able to solve for another 5 up here in block 1. Another way to see this one is you could have saw that there's a 5 right here that covers these 2 spots, and then this 5 cutting across, so there's a 5 right there. But Simon notices that and kind of works his way to see if he can solve all of those 5s. After he does that, he then turns his focus on the 6s and notices, okay, I got a 6 here, I got a 6 here, 2 spots for a 6 because of the 6 coming down column 4. Then he looks and notices that he can mark for some 4s. So there's 2 spots for 4 here because of this 4 and this 4 cutting across. By the way, this is Snyder notation. So anytime you only have 2 places a can can be in a 3x3 block, you make those marks. And then if you solve one of these cells, you can immediately solve the other one for that 4. It also helps identify and some advanced strategies that you might need later on. So he makes that mark with the 4s. But you can tell Simon, he's a little hesitant because he knows Shye likes to put, the big strategy kind of early on in the puzzle, and he doesn't expect that he can actually solve so much right away. So he's just kind of taking his time and putting in these Snyder notations to kind of build up and see where he might need to look in this puzzle. So after doing those 2 4s there, he says, hey, these are a pointing pair, right? So you got the 4 coming down here. The 4's limited to these 2 spots, which means the 4s are now limited to these 2 spots here in block 9, which is kind of nice. Pointing pairs are always good for us. After that, he turns his attention over to the 2s, and he says, okay, I got 2 cutting across here and 2 coming down here, so these have to be 2s. And then he notices kind of a similar pattern over here in block 9, and then up in column 3. And Simon's made this note before. When you have like Snyder notation, which is offset, usually it'll lend itself to even more advanced strategies versus the pointing pairs like with these 4s here. And so he's like, maybe there's something up with the 2s because there's only 2 spots for 2 here, here, and here. So it kind of piques his interest. And if you were to look at all the 2s here, you would be able to eliminate, and you'd have mostly Snyder notation in the blocks where 2s aren't present, in case you're wondering. All right, so after doing the 2s, he looks over here and then focuses on the 3s. And he notices some spot for 3s. He's like, oh yeah, they got a 3 coming up here, got a 3 coming up there, 2 spots for a 3 here. Looks over here in block 1. 2 spots for 3 there in block 1. And then he comes on down and he's like, oh, I gotta look at the 4. So he's kind of going down to like, hey, I looked all over the puzzle. Now I'm gonna kind of work my way up the digits. And when he sees the 4 cut across here and down here, he's like, oh, the 4s are limited to the same spot as the 2. So that is a hidden pair. So whenever you see something like this, 2 4, 2 4, you can make these marks. So you can put the 2 and the 4 in there and have a hidden pair. Super helpful. Then what Simon does is he looks at the 9s and he goes, okay, because there's 2 4 pair, this 9 coming down, now the 9s are limited. They're a claiming pair up here in block 7, which is great because now the 9s can't be anywhere else along row 7. So now they're limited, and this 9 coming down, they're limited to the same 2 spots as the 2. And so now you have another hidden pair. And I'm going to tell you, Simon didn't pick up on this right away, but these 2 spots, I'll call them wedges. This is like a key Shye type solving mechanism, I might call it. The other thing that should include you in right at the beginning is an awesome looking starting grid it looked kind of like a smiley face, and Simon pointed that out. But there's so many digits on column 1 and so many digits on column 9 that it's telegraphing. So it's Shye saying, you need to look over here. This is where you're going to get some solving. And then when she creates these little wedges in block 7 and 9, it creates a massive amount of restriction. And when you create those restriction, now that should really clue you in on this is where we need to focus to solve this puzzle. And you'll see, and I haven't given it away yet, you'll see that it will come into play here in just a little bit. So if you see this kind of interaction going on, Shye does this, Keen Lux does this, you want to keep your eye out because that's where the strategy is going to be. And remember, Shye loves to make puzzles that are not easily solved like by normal conventional methods. She wants something that's going to take some creativity, and that if you try to plug into a computer solver, it's going to be really awkward. And I'll actually show you that here in a little bit as well. But this is going to be really cool. You're going to want to see this. So after getting the 2, 9 hidden pair, Simon finds some ones. He's like, okay, where can the ones be? The one's coming down here. So there's 2 spots for a 1 in block 9. So this is kind of also a claiming pair. Ones can't be anywhere else along row 7. Then he looks at the 6s and looks up in block 3 and says, okay, I got this 6 here and I got these 2 6s. And he finally gets around and goes, okay, 2 spots for 6 right there. But this brings us up to our first pause the video moment. And I know you're ready to get into the nick of things, so I want to get you some interaction here and get you involved in this solve. So pause the video and solve for the 6 here in block 3 while I give you a few seconds. Okay, congratulations, you did it. You are an expert at finding pointing pairs. And for those of you who just want to enjoy the show, you can see Simon made these 2 marks to the 6, but then he realizes that the 6 is limited to 2 spots right here in block 6. So he marks these as a pointing pair, which eliminates the 6 from right there, and you can solve for the 6 here in row 2, column 9. And eliminates that spot. So congratulations if you spotted that. The other way to spot it would be the way you could have spotted the 5 over here in column 1. You look for the 6, can't be there, and this 6 can't be there, and that can be a 6. So 2 different ways to find it. But that's the way Simon did, was using that pointing pair of 6s. All right, back to the solve. Then he made the mark for the 6s. He solved for the 6, and then he's like, hey, I got 6 digits right here. Now Simon is cluing in on column 9, and that's really where Shye wants you to look. And so he says, well, I have 6 digits. I wonder what the other 3 are. Oh, it's going to be 4, 7, 8. So he puts in the 4, 7, 8 along column 9. And then he goes over, and with the symmetry of this puzzle, you should also look over here and go, okay, hey, I have 6 digits in column 1. What can I do about that? I can fill in 1, 7, 8 over here. And now it creates a 7, 8 here and here. And this is the moment you kind of want to stare at, because this is where Simon Anthony gets his trademark aha moment, where he's looking at it and he goes, there's something here, and I can make a solve. And so what he does, and it's pretty magical, it's pretty cool, he goes, I bet this cell right here is a 9. And he only took like maybe 10 seconds of thinking, and he says, I bet that cell's a 9. So I'm going to give you another pause the video moment. Pause the video and see if Simon is right. Can you solve this cell, row 1, column 2, for a 9 while I give you a few seconds? Congratulations if you did it. If you agree with Simon, you are correct. This is a 9, and I'm about to show you why it's a 9. And this is the trick. Shye has a lot they call one-steppers. You try to find the initial big trick that will clue you in on this solve, and this is it. It helps, and it has to do with the 7, 8 here and here. So let's go through it. It involves the technique. The easiest technique to use is called coloring. So by coloring, you're going to go, okay, I have a 7, 8 here, 7, 8 here. One of those, does one of these have to be a 7? And does one of these have to be an 8? Or are they going to both be 7s and both be 8s? That is really the question you're trying to answer. So what you want to do is start using some coloring. Well, first he solved this 9 right there. But here we go. Color right here. And he made this one an orange. And he said, this one is a green. And why can these two be separate? I'm about to show you. So what he noticed is one of these digits right here has to be a 1, and the other one has to be a 7 or an 8. So whatever this one's not, that's the other digit, right? So if a 7's down here, this has to be an 8. Same thing here. One of these has to be a 7, one of these has to be an 8. And how can we prove that? Well, if this green one, can up here, means that one of these two has to be orange. So it's got to be the opposite. And since one of these has to be orange, and you can't have 7 or 8 in this block, remember the nice little wedge? Well, that means the opposite, the green one's going to have to be up there. So we know up here is going to be a 7 or an 8 and a 9. Well, if that's green, that means green can't be here. We know orange is already coming down. So one of these has to be orange, and then one of these has to be green. So this is orange, this would be a green one, and this would be an orange. And then so the other way to look at it is go, okay, this is a green, let's say the green's 7, right? If that's 7, one of these has to be an 8, then one of these has to be a 7, it'd be green, then one of these has to be an 8, then one of these has to be a 7, and then this would be the 8. It would be the opposite. And this is how Simon kind of proved it. What he did instead is he said, hey, if I look right here, if this was a 7 and this was a 7, then you'd have no place to put a 7 here in block 8 because you can't have a 7 across the top. So one of these has to be a 7, one has to be an 8. But by using this coloring, you can kind of see pretty easily why this is a different color from that. So if that's a 7, that's an 8, that's an 8. If this is a 7, then that's an 8. Now apply it right here to our solve. What can this cell be? Can't be a 1, it can't be a 2. Can't be a 3, it can't be a 4, it can't be a 5 or a 6. And now we know one of these is a 7, one of those is an 8, so it can't be a 7 or an 8, it has to be a 9. So this cell has to be a 9. Now that is awesome, but we are not done. Keep watching because you do not want to miss what we're going to be doing next. This puzzle is far from being solved, but I am going to take you to our first what if moment. What if Simon didn't do the coloring? How can you make progress in this puzzle? And I'm about to show you that right now. Okay, if you didn't solve that for a 9, what you have to do to make any progress in the puzzle, it requires advanced strategies, the kind of things you don't really want to look for. And so to set up the next strategy, which is actually an alternate inference chain type 2 that will just eliminate one candidate, here's what you have to do. You have to go over here and realize that that's only a 3 and a 9. You can use this 2, 9 right there. You go over here and see, okay, I got a 2 cutting across. You saw this for a 9. So it'd be a pointing pair of 2s here. So know that there's a pointing pair of 2s right there. Then you'd look at this cell and go, okay, that's a 2, 8. And then this is a 7, 8. Okay, this is a whole lot of work. And you're going to see what we're going to do is basically try to see if we can eliminate something from this particular cell. So this is how it works. There's a strong link between these two 3s, right? Because there's only 2 of them in this column. So if that's strong link to this 3. You have a weak link to this 3 right here. Strong link to that 9 because they're in a bi-value cell. They always have a strong link with each other. So you're making a big alternate inference chain. Strong, weak, strong. Weak to this 9, strong to this 2. Weak to this 2, strong to this 2. If you'll look, there's no other spots for 2. Because of this can't be a 2, and you got a 2 right there. Strong to that 2. Weak to this 2, strong to this 8 because it's bi-value cell. Weak to this 8, strong to this 7. And so if you start in a 3 here, if that's not a 3, this is a 7. This is called an alternate inference chain type 2. And what it means is you can eliminate the start cell from the end. You can eliminate the start candidate from the end cell and the end candidate from the start cell. So there's no 3 down here, but this 7, you can eliminate a 7 from that cell. So all that work would get you to eliminate a 7 right there. Now, does that immediately get you to solve the puzzle? No. You have to do 4 more discontinuous loops or alternate inference chains to get any more progress. Then you'll create a couple of pointing pairs. There's also a jellyfish. It's ridiculous the amount of work. An XY chain gets thrown in there. The amount of work you'd have to do to get to a part where this puzzle becomes manageable to solve. The computer solver does not see it the way that Simon did or the way Shye intended it. Very hard to bypass the logic here. You really have to find the coloring. Now, let's go back to the solve. All right, after solving this for a 9, let's remove the coloring because Simon didn't do all this coloring at the bottom here, so I'll get rid of that. He then proceeded to do some Snyder notation. So he marked 2 9s right there, and he's like, 7 8 affected not only this cell, but this cell right here. So what could this be? And originally he goes, that could be a 2 or a 9 if you look at everything else, but then he's like, I have this pointing pair here, so that can't be a 9, that has to be a 2. So he marked that for a 2, and then he's able to come down here, actually over here, and go, I made that 9, so this has to be a 9 right here. And so he did the 9 in row 7, column 3, and then he went up into block 3 and said, it only, a 9 cutting across, only 2 spots for a 9. I'll make those marks for the 9. So we're not done yet. Yeah, we started with the coloring. There's going to be more coloring, so get excited about that. But we still have to figure out, what's the 7, what's the 8. And so we went back to the normal solving to try to make more progress in the puzzle. Not sure if there's going to be more advanced strategies, but the coloring is still going to be in play. So after marking those 2 9s, he's able to solve for a 2 down here because he looked down and said, I solved this 2 right here, so now I can solve the 2 9 down there. So he solves the 2 there and the 9 there. And after solving those 2 and the 9, he looks up and goes, I just solved the 9, so this is going to no longer be a 9. We can solve that for a 9 in row 3, column 8. And then I just, remove that 3 so I can actually solve for 3 in row 1, column 8. So in row 3, column 7, it's now got to be a 7 8, and then he turns it green. So he's like, we still haven't figured out the 7 8, so I'm going to make this a green thing. This is really common in variant Sudokus when you're trying to figure out coloring, kind of do the odds and evens. So this is pretty neat, and again, it works well in some classic Sudokus, like this particular one. After that 7 8, then sees, I haven't solved the 2 and the 4 down here, so I can solve that for a 2. I can solve that for a 4 because of this 2 right here. And solving the 2 and the 4, now he's able to mark. He does some more Snyder notation in block 5. All right, only 2 spots for a 2 there, so I'll make those marks. Then I go, this is a pointing pair of 2, so the pointing pair, this can no longer be a 2. You got the 2 right here, and you got the 2 coming up, so there's only 1 spot for a 2 here in block 4. So he marks that 2 in row 4, column 2. Then he looks up in the block 2 and says, where can a 2 be up here? It's either going to be column 5 or 6 up there in row 1, and then goes back down here to block 7. So he's not quite solved, not quite cracked the puzzle. And he's like, 1 7 8. This is going to be a 7 8. And what color can this be? Well, if this is green, this is going to be orange. So this has to be green as well. So he makes that mark as a green 7 8. And he then notices that row 4, column 3 here is a naked single. It's an 8. And the reason being is I got to look for some restrictions. I see 1 6 8 across here, and there's a 6 and a 1 right there, so this has to be an 8. However, Simon doesn't solve this for an 8 right away. Instead, he says, the 1 and 6 have to be over here. So he looks over here and goes, this one has to be a 6, so that has to be the 1. And so he solves for the 6 and the 1, but doesn't solve the 8 right away. Probably slow down the solve a little bit, because remember, we're trying to figure out 7s and 8s because of the coloring. But, it's Simon. He recovered okay. So he does that, the 6 and the 1. Then he follows this one and says, I can solve for the 1 down here in row 7, column 7. Then he fills and goes, this is a 4 7 8. So this cell right here is now a 7 8, and it's going to be orange, right? Because of this green one right there. Then after that, he says, this is a naked pair, 7 8, and he makes that one orange because he's still curious about the coloring. So did that in row 5, column 7. Then he's able to go back and he solves for the 8 now in row 4, column 3. After solving that 8, he decides, he's like, I'm still kind of blocked. He should have stayed here because this is where the solving and the way you're going to unravel the 7 8 is by looking here in block 4. But Simon doesn't do that. So keep your Eyes open. You're going to want to see what he does next, though. He said, we go over here. He goes, okay, this has to be 4, 7, 8. So he makes the 4, 7, 8 mark. Then he comes back and goes, okay, if I'm looking in here, I got this 6. Where can the 6 be? It's got to be in row 6, column 2. So now this has to be a 7. And once he marks this 7, Simon still didn't know if the 7 was green or orange. But look right now. You can figure out which digit is green and which one's orange, can't you? Yes, hopefully you look across and see this right here and go, okay, this is a 7, 8 is an orange. Simon doesn't see it right away. In fact, it takes a few seconds. You're looking at the screen, and he gets bogged down finishing up column 3. So he goes up here instead, and he goes, okay, I need to fill out a 3 to 4 right there, and then this is going to be your 7, 8, and that's going to be orange. So he does some more coloring when he could have started solving. But that's, it's easy to kind of be heads down when you're doing that kind of a solve. So he did that, then realizes, okay, I got a 3 here, and I got 3 coming up, so 3 can't be there. So the 3s are a pointing pair, and so that means this cannot be a 3. So he solves the 3 and the 4 right there. So that's 3 and the 4. After that, he now solves for the 4 right here because he sees, okay, I got 7, 8, naked pair. This has got to be a 4. After solving the 4, he makes some more Snyder notations. I got the 4 here, boom. 2 spots for 4. Now he finally spots the 7. He goes, oh, I now know what's orange and what's green. And he says, orange is 8. And so at that point, it all speeds up a little bit. So he gets the 8 in row 5, column 7, the 8 in row 7, column 8, the 8 in row 1, column 9. Then he comes down and gets the 7 in row 3, column 7, the 7 in row 2, column 1, and the 7 down here in row 7, column 2. And then he makes row 5, column 3 a green 7, and row 4, column 3 a green 8, an orange 8. And he kept coloring even after he had figured all this out. I think, he was just trying to help him figure out he got all of the 7s and the 8s. Hey, whatever works for you. So he did that, and then he does solve the 8 up here, and then he goes, okay, I got a 1, 8 right there. So he's not like, oh, I still haven't really quite cracked it. So he's still looking at his marks to figure out where we go. So that's why I said, hey, we're not done. You want to keep watching. All right, so he gets the 1, 8 in block 7. Then he comes over here and goes, okay, there's a 4, 7 here in block 9. And he's like, can I solve for one of those? Yes, because he's now then sees this 4 and goes, okay, I can figure out what these digits are. That's a 4, and that's a 7. After doing 4 and a 7, he colors the 7 green, okay. And then he looks for the 7s. He says, only one spot for a 7 up here. And so he colors that 7 green, row 8, column 4. And then he looks up to the top and goes, okay, I got a 7 up there, row 1, column 5. And I just moved that 2 so I can solve for the 2 immediately. And then he looks down and goes, okay, where can a 2 be down here in block 5? It's going to be right there. Then he's just kind of looking up and down column 5. And he notices, all right, what can I solve? He actually looks in this cell right here. And he goes, okay, I need a 3, 8, 9. I got the 9, and I got the 3. So that's actually going to be an 8. So he solves that 8 right there. And then he goes, oh, can I figure the rest of this column? Nope, it's got to be a 1, 6. So he just does the 1, 6. And then he comes across and does his full house up here. So put that one for full house. Looks down here in block 5 and goes, okay, the 1s have got to be in these 2 spots right there. But he also figures out that the 6s are in the same 2 spots. So anytime you're making these marks, Snyder marks, and you get the same 2 cants in the same 2 blocks, the 1s and 6s are both here in the same 2 cells. Whatever else you have marked, like this 3, that gets nudged out. There's no room for that 3. So that cannot be a 3. Now we can solve the other candidate that's marked for 3 for the 3. So he solves that for 3, solves that for a 4. After that, comes back up here and goes, okay, I need an 8 and a 9 on column 4. There's my 8. So he solves that for a 9, and then he solves for the 8 in the complete column 4. After completing column 4, he now fixes the 8 and the 1 over there, solves the 8 and the 1. And then after the 8 and the 1 over there, he looks and figures out that he can solve for the 6, and he can solve for the 1 and finish up column 5. After that, he makes another solve for the 6 right there. And then after the 6 in row 5, column 6, he solves the 8 in row 6, column 6, solves for the 3 in row 2, column 6, the 1 in row 8, column 6, the 9 in row 6, row 9, column 6. Thought he was done, and he's like, oh, nope, I got 2 more cells over here. So he looks quickly, and he goes, okay, one of these has got to be a 4, and one of those has got to be a 7. So he marks the 7, he marks the 4, and he's done. You think you got coloring figured out? Well, check out this other video of a solve I did of a Keenlux puzzle where it takes coloring to a new degree. Don't forget to buy me a coffee link. Thank you so much for watching.